In 1980 and again in 2010, a poll had asked a random sample of 1,000 U.S. citizens, are you in favor of the death penalty if a person is convicted of murder? In 1980, the proportion who said yes was 0.66. In 2010, it was 0.64. We want to know if this provides evidence that the proportion of citizens favoring the death penalty was higher back in 1980 than it was in 2010. P1 will represent the 1980 proportion and P2 the 2010 proportion. We're supposed to first state the null and alternative hypotheses. So we have two groups of data. So we're comparing P1 and P2. This is categorical data, which is why we're dealing with proportions, because what we're looking at is just a yes or no question. Do you favor or not favor the death penalty? In terms of our question, we want to know if it's higher in 1980, and 1980 is P1. So our alternative hypothesis will be that the difference is positive, and this is the same as stating that P1 is greater than P2. So this is a right-tailed test. The sample value for this problem then would be the difference in the two sample proportions, and so we had a sample proportion of 0.66 and 0.64 for the two different years, so our difference is 0.02. So the question is 0.02 likely or not if the null is true and the population difference would be a 0? So we need to create the randomization distribution. And what are we assuming here? We're looking at the distribution under the fact that the null is true. So it should be centered at our null value here of 0 when we simulate. In other words, we're assuming that there is no difference between these 2 years, 1980 and 2010. And we're looking to see then if that is the truth, is our value of 0.02 likely or not? So to get the p-value, we would go to StatKey. We're looking at a randomization test for a difference in proportions. And here you can enter your own data. So we can go to Edit Data. Our group 1 count would be how many people. If we have 66% or 0.66 out of 1,000, that would be 660. And then our sample size was 1,000. And then group 2, 0.64 would be 640 out of 1,000. So it wants counts here, not the proportions. So we got to convert those to our counts. You can see over on the side for our original sample, we have a proportion 0.66, 0.64, and that difference we computed of 0.02. And so now we'll generate 1,000 samples. And what this gives us is the P1 hat minus P2 hat values that are likely if the null is true and there's no difference in the population values. And our question is, where's our 0.02? Is it likely or not? Just glancing at the randomization distribution, you can see 0.02 is pretty far in the middle. So we can calculate the area beyond it or to get a sense of where it is in the middle by clicking right tail, since we were doing greater than, and entering our sample value of 0.02. And what we get is 0.193 for our p-value. What is that telling us? That's a large value. So this is showing us that 0.02 as the sample value is likely if the null is true, which suggests that, sure, there could be no difference in the proportions for the two populations. So our p-value was 0.193. This is large, which would mean do not have evidence in favor of the alternative over the null. So we can't say the population proportion was higher in 1980. Okay, so here our sample data does not discredit this, so that means we can't say that we actually had a higher proportion in 1980.